Have you ever noticed something strange happening? You think about a pair of shoes. Suddenly, ads for those exact shoes are everywhere. Or maybe you ask your phone a question, and it answers you like a person. Face unlock, map rerouting around traffic, music playlist recommendation, smart home turning on the lights. This isn't magic. It's not a coincidence either. This is artificial intelligence, or AI. It has quietly become a part of our daily lives, on our phones, on our computers, in our cars. It's the new normal that just sort of showed up. You might hear AI and think of a science fiction movie. Maybe you picture robots taking over the world, or super smart computers that think for themselves. The truth is much simpler and a lot more useful. AI is just a tool, a very powerful tool, designed by people, to help people, not creating new life, making our lives easier, faster, more connected, solving problems that were once too big or too complicated, using the power of smart software. So why should you care about this right now? AI is no longer just for scientists and tech experts. It's for everyone, influencing the news you read, helping your doctor make better decisions, suggesting what you should watch on a Friday night. Understanding what AI is and what it is not is becoming a basic life skill. It's like learning how to use the internet a couple of decades ago. If you don't get the basics, you risk being left behind. Knowing how it works helps you use it better. It also helps you spot when it's not working so well. This isn't going to be a complicated lecture, I promise. We are not going to talk about complex code or confusing math. My goal is simple. I want to spend the next 15 minutes breaking it all down for you. We will use plain language. We'll use examples you already know. By the end, you'll understand AI fundamentals. You'll see how it affects you, and you'll feel more confident navigating this new world. So, grab a seat. Let's figure this out together. It's much less scary and much more interesting than you might think. Let's get started. Let's make a deal. You give me 15 minutes of your time. In return, I'll give you a clear map to the world of AI. This is about building a solid foundation. It's about getting comfortable with the concepts that are reshaping our future. We'll cut through the hype and the fear. We'll focus on what's real and what really matters to you. In our short time together, we are going to cover a few key areas. First, we'll define what AI actually is, using simple ideas. We'll talk about how it learns, almost like a student in a classroom. Next, we will explore where AI shows up in your day-to-day life. You might be surprised to find out you're already an experienced AI user. After that, we'll address the big questions, the myths and the worries that a lot of people have. Will a robot take my job? Is AI getting too smart for its own good? We will tackle these fears head-on with calm, realistic answers. Understanding the risks is just as important as understanding the benefits. Finally, we'll wrap up with some simple, practical tips. We'll talk about how to use AI tools safely and smartly. And I'll give you 2 easy next steps you can take to continue your learning journey. My promise is that by the end of this guide, you won't feel overwhelmed by AI anymore. You will feel empowered. You will have the confidence to talk about it. You will have the confidence to use it. You will have the confidence to think about its place in our world. So, let's begin this 15-minute journey. Your crash course in artificial intelligence starts right now. Let's do this. So, what exactly is artificial intelligence? Let's forget the killer robots and the spaceships for a minute. At its core, AI is simply a type of computer program that can learn and make decisions. Think about the software you use every day, like a calculator. You type in 2 plus 2, and it always gives you 4. It follows a strict set of rules written by a programmer. It can't do anything else. It doesn't learn from its calculations. It just follows its instructions, perfectly and predictably, every single time. That's regular software. It's smart in its own way, but it's rigid. It's stuck in its programming. AI is different. It's more flexible. Instead of just following a long list of detailed instructions, we design AI to figure things out on its own. It's like the difference between giving someone a fish and teaching them how to fish. Regular software is the person you give a fish to. It does one thing well. AI is the person who learns how to fish. It can adapt to different situations. It can learn from experience and get better over time. This ability to learn is the magic ingredient. It's what separates a simple computer program from something we can genuinely call intelligent. A regular program designed to sort photos would need a programmer to write a rule for every single possibility. A rule for a cat's pointy ears, a rule for a dog's floppy ears, a rule for a hamster's tiny nose. It would be an impossible task. An AI, on the other hand, learns by looking at examples. You don't tell it the rules for what a cat looks like. You just show it thousands and thousands of pictures of cats. It starts to recognize the patterns by itself. It builds its own understanding. So when you hear AI, don't think of a brain in a jar. Think of a very advanced student. It's a piece of software that has been trained, not just programmed. It's designed to recognize patterns, make predictions, and adapt based on new information. It's not conscious. It doesn't have feelings or desires. It's a highly sophisticated tool for pattern recognition. It's a new kind of software that can tackle problems that were once too messy and complex for old-school computer code. It's a step up, a new chapter in what computers can do for us. To understand AI, let's use a simple metaphor: a student in a classroom. Imagine you want to teach a student to tell the difference between a cat and a dog. With a traditional approach, you'd give them a long checklist. Does it have pointy ears? Does it bark? Does it have whiskers? The student would follow the list, but they'd get stuck easily. What about a cat with folded ears? Or a dog that doesn't bark? The checklist would fail. This is like old software, rigid, can't handle the messiness of the real world. Now, how does an AI learn? This is called machine learning. Instead of a checklist, you give the AI student a massive library of photos. 1 million pictures labeled cat. 1 million pictures labeled dog. No rules, just look at these examples and figure it out. The AI student studies every single pixel. It looks for commonalities, textures, shapes, colors, hidden patterns that define catness and dogness. A student that never gets tired, never gets bored, can study millions of examples in the blink of an eye. This process is called training. During training, the AI makes guesses. It might see a chihuahua and guess cat. The picture is labeled dog. It learns from the mistake. It adjusts its internal logic, updates its own set of rules to be a bit better next time. It repeats this millions of times. Each mistake makes it smarter. It refines its understanding with every example, like taking practice tests over and over, getting feedback after each question until all answers are right. This is why data matters. The data is the textbook. More examples. Better performance. A model trained on a few hundred cat photos gets confused. Hundreds of millions, showing every breed, every pose, every kind of lighting, will become incredibly accurate. This is the core concept of machine learning. It's not about genius programmers writing perfect code. It's about feeding a learning algorithm a huge amount of data and letting it build its own expertise, its own model of the world. After all that training, what does the AI actually create? It creates something called a model. You can think of a model like a finished cookbook. After studying thousands of recipes and watching countless chefs, our student doesn't just have a list of ingredients. They have developed an intuition for cooking. They have a mental model of how flavors and textures work together. They can look at a pile of ingredients and invent a new dish that will probably taste good. The AI model is similar. It's not just a database of cat pictures. It's a compressed, statistical understanding of what a cat looks like. This model is a complex web of connections, a giant pattern-matching machine. When you show it a new photo it has never seen before, it doesn't compare it to every photo in its training data. That would be too slow. Instead, it runs the new photo through its internal model. It checks the patterns in the new image against the patterns it learned during training. It looks for the statistical signals of catness, the combination of shapes, lines, textures that, based on its experience, strongly suggest it is looking at a cat. It then makes a prediction, a highly educated guess. But here is the most important thing to remember. The AI doesn't think like a human. It doesn't understand what a cat is. It doesn't know that cats are soft, that they purr, or that they like to knock things off shelves. It has no concept of cat. All it has is a very, very sophisticated mathematical model that says, when pixels are arranged in this particular pattern, there is a high probability that humans label it a cat. It's a master of correlation, not causation. It finds patterns, but it doesn't understand the meaning behind them. It's just really, really good at a game of statistical matching. This is a crucial limitation. AI systems can seem incredibly smart, but they are also very narrow. An AI trained to identify cats cannot suddenly start writing poetry or diagnosing diseases. It only knows what it was trained on. And because it's just following patterns, it can be fooled. If you show it something that doesn't fit the patterns it has learned, it can make strange and confident mistakes. Understanding this helps you see AI for what it is, a powerful tool for specific tasks, not a replacement for human consciousness, common sense, or true understanding. It's a brilliant pattern finder, and that's it. You might think that using AI is something you have to choose to do, like downloading a special app. But the truth is, if you have a smartphone, you're already using AI all day, every day. Think about the last time you unlocked your phone just by looking at it. That's AI. A model trained on your face recognizes its unique patterns and grants you access. Faster and often more secure than typing a password. Let's talk about your phone's camera. Point it at a person and a little yellow box appears around their face. That's AI. The camera then automatically focuses on the person. It adjusts the lighting to make them look their best. It may blur the background for a portrait look. You don't fiddle with settings. You just point and shoot. The AI does the heavy lifting, a tiny expert photographer inside your device. And what about your digital assistant? Say, "Hey Siri," "Hey Google," "Alexa." You are speaking directly to an AI. First, it converts your speech to text. That's hard because of accents, tones, and background noises. Then a second layer interprets your request. Are you asking for the weather? Trying to set a timer? Wanting to play a specific song? It happens instantly, feeling like a natural conversation. Even navigation is powered by AI. A map app finds the fastest way home, not just the shortest route. AI analyzes real-time traffic from thousands of drivers. It spots a traffic jam miles ahead. It predicts how long the delay will be. And it instantly reroutes you to save time. Constantly learning and updating, your map becomes a dynamic problem solver. Your phone is a pocket-sized assistant. AI is the brain helping you navigate your day with ease. Beyond the basic functions of your phone, AI is constantly working behind the scenes to tailor your digital world specifically to you. It's the ultimate personalization engine. A great example is the recommendation system you see on services like Netflix or Spotify. These platforms have a massive library of content, far too much for any one person to browse through. So, how do they help you find something you'll actually like? They use AI to study your viewing or listening habits. The AI then compares your patterns to the patterns of millions of other users. It finds people with similar tastes to yours. It sees that people who loved movie A and movie B also tended to love movie C. Since you've already watched A and B, the AI predicts there's a very high chance you'll also enjoy C. So, it puts that movie right on your home screen. It's an algorithm that has become an expert matchmaker, connecting you with content it believes you will love, making discovery feel effortless and almost magical. This personalization extends to your email inbox as well. Do you ever wonder how your email provider knows which messages are important and which are just junk? That's your AI-powered spam filter. It has been trained on billions of examples of both legitimate emails and spam messages. It learns to recognize the telltale signs of junk mail: suspicious links, strange formatting, keywords commonly used in scams. It automatically sorts these messages out of your main inbox, saving you from a daily flood of unwanted clutter and protecting you from potential security risks without you lifting a finger. Even online shopping is deeply shaped by AI. The products you see on the front page, the "customers who bought this also bought" suggestions, the ads that follow you to other websites, are all driven by AI. It learns from your search history, the items you click on, the things you buy. It builds a profile of your interests and uses it to show you things it predicts you are likely to purchase. For you, it can be a convenient way to discover new products, making your online experience feel uniquely curated for your needs. The impact of AI goes far beyond convenience and entertainment. It is starting to play a critical role in the most important areas of our lives, especially in healthcare. Doctors and scientists now use AI to detect diseases earlier and more accurately. Radiologists review hundreds of medical scans every day. A tiny, almost invisible spot on a scan could be the earliest sign of cancer, and it can be easy for the human eye to miss. This is where AI becomes an incredible assistant. AI models are trained on millions of labeled medical scans. The AI learns to spot subtle patterns. When a radiologist reviews a new scan, the AI analyzes it too. It highlights areas of concern for the doctor to inspect. It acts as a second pair of eyes, one that never gets tired. That can lead to earlier diagnosis, often the key to successful treatment. Beyond the hospital, AI helps make our world safer in direct ways. Many banks now use sophisticated AI to protect you from fraud. These systems learn your normal spending patterns, where you shop, how much you usually spend, what time of day you make purchases. If a transaction doesn't fit your profile, for example, a large purchase in a different country in the middle of the night, the AI flags it. It may automatically block the transaction and send an alert, stopping criminals before they can cause real damage to your finances. We thought of creativity as a uniquely human skill, but AI is starting to change that perception. It's not replacing human creativity, but it is providing us with powerful new tools that can augment it. A user simply types a text description, a prompt, like a photorealistic painting of an astronaut riding a horse on Mars. The AI, trained on billions of images and text, understands the request. It then generates a brand new, completely original image that matches the prompt. This lets people without traditional drawing skills bring wild ideas to life. It's a new form of collaboration between human imagination and machine execution. AI is also becoming a valuable partner for writers. AI writing assistants can help you brainstorm ideas, overcome writer's block, improve your grammar and style. It's not about letting the AI do all the work. It's about using it as a sounding board, a tireless editor, a source of inspiration that helps you communicate more effectively. The world of music is also being transformed. A musician could hum a simple tune into a microphone and ask an AI to orchestrate it in the style of a full symphony orchestra. This lowers the barrier to entry for music production, giving more people the ability to create high-quality sounds without expensive equipment or years of training. AI is becoming a co-creator, a muse in the machine, that can unlock new possibilities and push the boundaries of what we consider art. So, we've talked about what AI does, but how does it really get built? Let's peel back the curtain. Imagine we want an AI that writes recipes. Think of it as a high-tech bakery. First, ingredients. For AI, the main ingredient is data. Lots and lots of data. Step 1. Data collection. gather hundreds of thousands of recipes. From the internet, from old cookbooks, from famous chefs, from grandma's secret notebooks, everything we can find. Next, prepare the ingredients. Data must be cleaned and organized. Check for mistakes, remove duplicates, make formats consistent. This step is critical. Messy data. Chuck weird AI. The final model depends on ingredient quality. Now, start baking. This is the training phase. The AI model is an apprentice baker. We give it the training data set. The AI reads the recipes, not memorizing, learning patterns. It learns titles. It learns ingredient lists. It learns step-by-step instructions. It notices flour and eggs often together. Training involves a lot of trial and error. At first, nonsense. It might suggest baking a fish with chocolate. Each mistake updates its internal logic. Repeat millions of times, like an apprentice making thousands of cakes. Eventually, logical, creative, delicious recipes. Training complete, the AI baker is ready for the next step. Our AI baker has learned from a huge cookbook, but what happens if that cookbook has some problems? Let's say, for example, that 90% of the recipes were for chocolate cakes. Our AI would become an absolute expert on chocolate cakes. But if you asked it for a recipe for a lemon tart or a simple loaf of bread, it would struggle. It might even try to add chocolate to the bread recipe. This is a simple way to understand a huge problem in AI called bias. An AI model is only as good and as fair as the data it's trained on. This becomes a much more serious issue when AI is used for important decisions. Imagine an AI used to screen job applications. If it was trained on historical data from a company that mostly hired men for engineering roles, the AI might learn an unfair pattern. It might learn to associate male names and traditionally male-coded hobbies with successful candidates. It wouldn't be doing this because it's sexist. It doesn't have opinions. It would simply be reflecting the bias present in its training data. This is why having diverse and representative data is so critical for building responsible AI. To create a truly skilled baker, we need to feed it a balanced diet of recipes from all around the world. Correcting for bias is one of the biggest challenges for AI developers today. It involves carefully auditing the data, and sometimes creating new synthetic data to fill in the gaps and balance the scales. It's a constant effort to make sure the AI doesn't just repeat the mistakes of the past. Ultimately, this means we can't just blindly trust an AI's output. We always have to ask, what data was this trained on? Could that data have contained biases? An AI might seem objective because it's a machine, but it can inherit all of our human prejudices if we're not careful. When an AI gives you a surprising or questionable result, it might not be a brilliant insight. It might just be the result of a poor diet, a limited set of ingredients that gave it a warped view of the world. Once our AI baker has finished its training, it's not yet ready to open for business. The next stage is testing. Flowchart, data collection, model training, model testing, check, deployment, user on phone. We give the AI a new set of tasks it has never seen before. Example task. Create a recipe for a gluten-free vegan birthday cake with strawberries. Human experts then evaluate the result. Does the recipe make sense? Are the ingredients and proportions correct? Would it actually taste good? Testing reveals the model's capabilities and its limitations. We push it to see where it breaks. What if we ask for a transparent potato recipe? A good model should say it can't fulfill that. A bad model might spit out gibberish. We measure accuracy, creativity, and safety. Only after passing these tests do we let it interact with real people. It's a quality control step you can't skip. After passing, the model is ready for deployment, the grand opening. Deployment rockers making the model available for people, on a website where you type ingredients and get a recipe, or integrated into a smart kitchen appliance. The model is large, hosted on powerful cloud servers. You make a request from your phone or computer, the request is sent to servers, the model processes it, and the result is returned in a fraction of a second. But the work doesn't stop. creators constantly monitor real-world performance. They watch what requests users make and the results the AI gives. Are users happy? Any new or unexpected mistakes? This feedback is extremely valuable. It helps find new problems and sources of bias missed in testing. That feedback is used to refine the model and release improved versions. The AI is always a work in progress, updated based on interactions with you. All this amazing technology doesn't just happen by magic. It requires an enormous amount of computer power. Training a large, sophisticated AI model is an incredibly energy-intensive process. It involves thousands of specialized, high-powered computer chips known as GPUs, all running at full capacity for weeks or even months on end. This is the part of AI that you don't see. It's the massive, hidden infrastructure that makes the magic on your screen possible. Every time it made a mistake and adjusted its internal logic, it was performing a complex mathematical calculation. Now multiply that by billions or even trillions. All those calculations require electricity. These servers generate a tremendous amount of heat, so they also require massive cooling systems to keep them from overheating. The total energy consumption can be staggering, equivalent to the electricity usage of a small city. This has become a major concern for the tech industry and for environmentalists. As AI models get bigger and more powerful, their energy appetite is growing right along with them. Companies are now in a race to find more efficient ways to train and run these models. They are designing new, more energy-efficient computer chips. They are also working on ways to make the AI learning process smarter. Moreover, many of the big tech companies are investing heavily in renewable energy sources, like wind power and solar power, to run their data centers. As a user, it's good to be aware that every time you ask an AI to generate an image or write a paragraph, there's a real-world energy cost associated with it. This doesn't mean you shouldn't use these tools, but it reminds us that AI is not a weightless, cloud-based fantasy. It is a physical system with a real environmental footprint, and making it greener is one of the next big challenges for the industry. Now for the part that keeps people up at night. The big, scary questions about AI. Will AI take all our jobs? The honest answer is that yes, AI will change the job market. Some jobs, especially those that involve repetitive tasks, data analysis, may be automated. But history has shown us that technology tends to create new jobs, even as it displaces old ones. When the automobile was invented, jobs for blacksmiths who made horseshoes declined. New jobs for mechanics rose. The more realistic picture is that AI will become a partner, a co-pilot, for many professions. A doctor might use AI to analyze patient data more quickly, but the human doctor is still needed for empathy and complex diagnosis. A graphic designer might use AI to generate initial ideas, but a human designer is needed to refine ideas and add a unique creative touch. The jobs of the future will likely involve working alongside AI, using it as a tool to become more efficient and capable. Then there's the Hollywood myth. Will AI become sentient, wake up, and decide it doesn't like us anymore? This idea comes from a misunderstanding of what AI is. It doesn't think or feel. An AI that can beat a grandmaster at chess has no more understanding of the game than a calculator has of mathematics. The leap from a sophisticated pattern finder to a self-aware, conscious being is astronomically large, and we are nowhere near it. It remains firmly in the realm of science fiction. A more immediate and real risk is the issue of fairness and bias. Is AI inherently fair? No, it is not. An AI model is a mirror that reflects the data it was trained on, warts and all. This is a very real danger when AI is used for critical decisions like loan applications, criminal justice, or hiring. The risk isn't that AI will become evil, The risk is that it will mindlessly and efficiently perpetuate the unfairness that already exists in our world, creating a system that seems objective but is actually deeply flawed. So how do we navigate this new world and use these powerful tools without getting into trouble? It starts with a healthy dose of skepticism. Check sources. The first rule of using AI is to check your sources. If an AI gives you a factual answer, especially for something important, verify it with a trusted source. AI models can hallucinate. They can make things up with great confidence. They can invent historical facts. They can create fake scientific citations. Always treat AI-generated information as a starting point, not absolute truth. Think of it as a very smart but sometimes unreliable intern. Protect data. Next, protect your personal data. Be mindful of what you share with AI tools, especially free ones. Avoid inputting sensitive details, your address, financial information, private conversations. Review your social media and account privacy settings. Good digital hygiene is your first line of defense. Spot fakes. Another growing risk is deepfakes. Deepfakes are AI-generated images or videos that can make it look like someone did or said something they never did. Learning to spot fakes is a crucial skill. Watch for unnatural blinking. Watch for strange lighting. Watch for weird blurring around the edges of a face. If a shocking video of a public figure appears, wait for reputable news confirmation before believing or sharing. Be critical of media. I want to leave you with 2 simple, concrete steps you can take today to continue your journey. The first step is all about getting comfortable. Try out one trusted AI tool for yourself. Use it for something simple and low stakes. See how it responds. Your second step is about becoming a smarter digital citizen. This week, learn one new thing about your own data privacy. Pick one app you use every day. Open its settings and find the privacy section. You don't have to change anything, just become aware. And that's it. That's your mission. Try one tool and check one setting. These small steps will lead to greater understanding and control. We started by demystifying AI, not as a sci-fi monster, but as a new kind of software, a student that learns from data. We saw how AI is woven into daily life, making things more personal, more efficient, and sometimes more creative. Key lesson: AI is only as good as the data it's fed. They're mirrors reflecting the world we show them, complete with our flaws and prejudices. This understanding shifts us from passive consumers to critical thinkers who question results and demand better, fairer systems. We replaced Hollywood hype with a realistic view. Real challenge: job transitions. Real challenge: algorithmic bias. Real challenge: privacy. Your new superpower isn't coding or advanced math. It's curiosity. Ask good questions. How does this work? What data was it trained on? Is this result fair? Is this information true? Armed with knowledge and skepticism, you're not a spectator. You're an active participant, ready to navigate AI's future with confidence. The future isn't written yet. We get to write it together. Thanks for spending this time with me. Now go get started.